Okay, AI in language. Got to be thinking Transformers.
Pretty sure.
These things are like rock stars,
Yeah.
Chat GPT, advanced translation,
It's
all this incredible tech.
They've really changed the game.
And today, we're going behind the curtain with the OG research.
Attention is all you need.
Yeah. Getting into how Transformers work
Yeah.
can feel a bit like building a rocket from scratch.
Right.
That's why we're here,
Yeah.
to break down this tech
Absolutely.
into aha moments.
Yeah, we're going to show you not just the what, but the why.
Okay.
Because
complete
once
it.
you get the elegance of the design, it's just like,
Yeah.
it changes everything.
So first things first.
Yeah.
Imagine a transformer like a super sophisticated translator.
Okay.
Two main parts.
Yeah.
The encoder
Right.
understands the message,
Yeah.
and then the decoder
Right.
crafts the output,
Based on that understanding.
passing a secret code.
You take the input, say another language, and you transform it, you encode it, and then you decode it, and out comes the translation.
Okay, but here's where it gets interesting.
Okay.
Traditional models, they kind of plot it along, right?
Bit by bit, yeah.
Word by word.
Yeah.
But Transformers, totally different.
Yeah, self-attention.
Self-attended.
They can look at all the words at the same time, rather than going one by one.
So they see the whole thing.
It's a whole sentence, yeah.
At once.
Instantly, yeah.
So it's like,
Grasping all those relationships.
instead of looking at each brushstroke,
Yeah,
you're taking in the whole painting.
exactly, yeah.
You get so much more.
That's a really good way to put it.
Right.
This parallel processing.
Yeah.
It's a game changer.
Right.
Speed and efficiency.
Okay.
You're training these models on massive, massive data sets.
Right.
So if you can do all in parallel, huge advantage.
So it's like a super brain
Yeah.
reading a whole library instantly.
Yeah, pretty much.
Versus us, just like one page.
Yeah.
Okay, no wonder they're so good.
Exactly.
Now let's talk about the heart of it all. Attention.
Okay, this is key. This is what lets Transformers focus on the good stuff.
Right, like if you walk into a crowded room,
Yeah.
you notice certain things first.
Your attention is drawn to certain things.
Right.
Right?
And Transformers do the same thing, but with language.
Exactly, yeah. They use scaled dot product attention.
What? Yeah.
Oh.
It's basically
Lad down.
you're calculating a score for how important each word is to each other word.
Okay.
So every word is like, hey, how important are you to me?
Interesting.
And you, how important are you to me?
Yeah.
And so on. Yeah.
So it's more like a web then.
Yeah, kind of. It's not just linear.
Okay.
And what's really cool is there's not just one attention head,
Multiple.
multiple heads.
Like a hydra.
Like a hydra, yeah. You can think of it as like each one is a specialist.
Okay.
One might be looking for the verb.
One might be looking for the subject,
Makes sense.
and so on. So you get a much richer picture.
Wow. Okay, so multiple heads,
Yeah.
each with their own specialty.
Yeah.
And that gives you...
A much richer understanding of the sentence
Okay.
than just like going one by one.
This is already blowing my mind.
Yeah.
Okay, so we've got these multiple attention heads, like a hydra, right? Each one with their own specialty,
Yeah, it's a good analogy.
working in parallel, processing everything at once.
Right. And because of that,
But
they need a way to keep track of the order of the words.
oh, right.
If it's all at the same time.
Position, yeah.
Yeah, exactly.
How do they keep it all straight?
So that's where positional encoding comes in.
Okay.
You basically give each word a unique code, like a timestamp.
I see.
Tells the transformer where it is in the sequence.
Okay, so...
So words close together have more similar codes.
Gotcha.
And then words further apart, more distinct.
Like giving each word a little flag?
Kinda, yeah.
I'm number 3.
Exactly.
I'm in the back.
Yeah, but instead of flags, it's math.
Right.
But that positional info,
Yeah.
it gets integrated into the whole process.
So it's not just the words.
It's not just knowing the word, it's knowing the order.
It's the order, the sequence.
That's how they get the nuances.
Okay, that makes sense.
This intricate dance between attention.
So it's like the dance performance, right?
Yeah, I like that.
You need to know where to stand,
You got it.
when to come in.
Exactly.
Otherwise, it's chaos.
And speaking of performance,
Right.
let's talk about training.
Yeah. How do these things actually learn?
Because they don't just magically work, right?
Wow, they need
Data.
data, right? Like
Tons of it.
like sending it to boot camp.
Yeah, like a boot camp for language.
Mountains of data.
So you're feeding it books, articles, like everything.
So it can learn the patterns.
It's absorbing all these patterns, yeah.
Okay.
And during this training, right, you give it input.
Like what?
Let's say an English sentence, and it has to predict, maybe, the French translation.
Okay.
And
right.
then you measure the difference, the
Yeah.
prediction, and the real thing.
How far off it is.
Exactly, and that's the loss.
The bigger the loss.
The worse the prediction.
Like missing the target, right?
Exactly.
Okay.
So the goal is to minimize that loss.
Make it as small as possible.
As close as possible to the actual translation.
Right.
And this is where it gets really cool.
Okay.
Because we can control how it learns.
We can?
Yeah, with the learning rate.
The learning rate.
Yeah, it's like a speed dial.
Oh, interesting.
How fast does it learn from the feedback?
Okay. Too fast, too slow.
Exactly. You got to find that sweet spot.
The Goldilocks zone.
Exactly. Not too hot, not too cold.
I like it.
But even with all that,
Yeah.
there's a risk of the model getting too confident.
Too confident.
Yeah, too sure of itself.
Like it knows everything.
Exactly. And that can make it inflexible.
Oh, I see.
So that's where label smoothing comes in.
Label smoothing. Okay.
It's like we're introducing a bit of uncertainty.
Uncertainty.
Yeah, instead of saying you're right or you're wrong,
So it's more like,
it's more like you're kind of close, but...
don't get cocky.
Exactly.
Like-
It's always more to learn.
Okay, so it keeps it humble.
It keeps it open to new information,
I like it.
which is crucial for real-world stuff.
Right. Because the real world is messy.
Exactly. It's not always clear-cut.
Okay, so we've got the data.
Yeah.
We're training it.
We're keeping it humble.
But how does this all come together?
Well, let's look at an example,
Yeah, give me an example.
like machine translation.
Okay,
One area, transformers really shine.
perfect.
Say you have a sentence in German.
Okay,
Das Wetter ist heute wunderschön.
okay. I don't speak German, but I'm picturing sunshine.
You got it. It means the weather is beautiful today.
And the transformer can just, like,
The transformer can translate that,
wow.
just like that.
Okay, but how?
Well, it's been trained on tons of German English text.
Right.
So it's seen this kind of thing before.
But it still has to, like, understand the sentence.
It does. It's doing these incredible computations.
It's like it takes a snapshot
Yeah, kinda.
and then just, like, paints it in English.
That's a good way to put it.
Okay, that's super impressive.
But here's the really cool part.
There's more.
We're not just guessing how it does it.
What do you mean?
You can actually see what it's focusing on.
Wait, really?
Yeah, using attention maps.
The tension maps. Okay, now you're speaking my language.
We like visuals.
I love visuals. Tell me more.
Eh.
Attention maps. Okay, so we're about to see inside the brain of a transformer.
Kind of, yeah. It's like a heat map.
Okay.
Brighter the color, stronger the attention.
Okay, so it shows you what it's focusing on.
Exactly, at each step of the process.
So, in that German sentence with wunderschön, would it light up around beautiful?
Yeah, you'd see that connection, that link.
Wow, so it's like tracing the thought process
It really is how it connects the meaning.
across languages.
Yeah.
That's incredible.
And it's not just individual words.
Yeah.
It also shows how the encoder and decoder are, like, talking to each other.
Wait, hold on. They're having a conversation
In a sense, yeah, the decoder will actually look back.
while it's doing the translation,
Exactly, using the attention map as a guide.
like a reference.
Yeah, making sure nothing gets lost.
Wow, they're in sync.
That's the beauty of it.
Okay, so wow, we've gone from self-attention
Yeah.
to positional encoding,
Label smoothing.
right? Label smoothing, keeping them humble.
Attention maps.
It's like we've cracked the code.
And the annotated transformer, it's been a great roadmap
It really has.
for understanding all of this.
It's like this complex thing, and then
Yeah.
it just clicks.
It all comes together.
We're not just talking about like secret messages anymore.
Right.
This is like the secrets of language itself.
And this is just the start.
There's more.
Oh, yeah, transformers, they're everywhere.
Like what?
Chatbots, for one,
Right.
generating text, even drug discovery,
Wow.
all kinds of fields.
It's like a whole new world.
It really is.
Well, transformers are changing the world.
One word at a time.
And you heard it here first on the deep dive.
That's right.
Until next time.